Hello, it's been a while since I posted something on this channel. So this is a short introductory video for a new course that I plan to upload along the way. It's not done yet, just some of it, and I hope I will be able to actually upload the full content of this course by the end of this fall semester. So as you can see here on the page, I would like to actually create a full course on Calculus 3 in the same traditional style, so to speak, that those of you who watched some of my videos are already aware of. I prefer this as close to a classroom experience as possible, this type of online teaching. That is to say, I prefer basically to use the screen as I actually use a whiteboard in an actual classroom. And ideally, the only difference it should be that there is no live interaction. But other than that, if the audience would just take notes, sit down, make the screen full screen and as large as possible, it should feel as close as possible to a real classroom. With some, of course, caveats or modifications, obviously, but that's the idea. I hesitated a little bit before I decided to undertake this this objective, because Calculus 3, it's going to be a little bit more challenging than other courses I went over already in this channel. Calculus 3 is more visually heavy, I should say, than other courses. There is a lot of three-dimensional visualization, drawing, so on and so forth. I'll get to that in a moment, which I think it's going to be a little bit more challenging on this type of device, which is writing tablet device, than in a regular classroom. Usually in a regular classroom you have far more space, whereas here is just basically the space of a big normal page. Now, of course, I can turn the pages and you're going to have probably more pages in a typical lecture than before, but it's still probably a little bit more crowded than in a regular classroom. But I think it's worthwhile in the end, both for my own selfish reasons, in the sense that I plan to use this as a backup for certain tasks, this type of material, for the students I'm teaching. But for the outside of my university audience, it should still be useful. Just be aware, especially those of you who didn't go over any of my videos, that while you are welcome actually to watch any lecture, in any order you want, I prefer to actually go over a full course from top to finish, in the sense that, to an extent, of course, lectures follow from one to another. In other words, if you decide, for instance, to just look at the lecture on double integrals, which is going to come later in this course, because that's what you want to actually get a refresher on, that's perfectly fine, but you really have to make sure you know all the material that precedes that section. So each of these lectures is not meant at all to be self-sufficient. Okay, I mean, so in other words, you need to know, to make sure that you know the prerequisites or the material that goes up to that section. So, for example, there's no point on reading something about vector functions if you didn't actually study or didn't go carefully over what vectors are and main vector operations, geometry of the vectors, and so on and so forth. There are plenty of videos on YouTube that give you crash courses on a single topic that are self-contained, so to speak. So I don't think, there's no problem if I'm sticking to a different way of going over a topic. So let me go over these bullet points before we get to the first lecture, and just to pinpoint a couple of things that you might need to be aware of before you go through the actual lectures. So be aware, first of all, that this typically is a 4 credit hours course, so it should be a little bit longer than a 3-hour course that you may take. Be aware that, let me actually use a different color here while I emphasize a couple of things. So be aware that in a typical 50 minutes lecture, so a typical 50 minutes lecture in class that might correspond to, on average, maybe 35 minutes of a video lecture. That is because, and that's why I'm going to talk about using the pause button later. That's because since this is not live and you can always stop the video to catch up on the computation or anything, or if you want to, you need a little bit more time to follow what goes on the page, you could always pause the video, and I'm aware of this feature. And for that reason, I don't take breaks. I don't make pauses that I normally do in a classroom when, of course, students don't have the ability to rewind my voice or, so that they can catch up or to stop me. So I stop myself. I mean, I take pauses or breaks, go slower, in other words. But here you have the pause button, and make sure you use it. And be aware that if a lecture, for example, looks like it's 60, 70 minutes, it means that you probably should cover that in 100 minutes time, either in one setting, or maybe you can break it down into 2 pieces and then go over it 2 days in a row or something like that. Lectures will be as long as needed to cover a topic, not how long it will take. So don't assume that every lecture is 50 minutes. Some of them will take longer than that. I like to take my time, especially if the topic is more difficult. So be aware of this aspect. Another remark here to make my to make it a little bit easier for my students. I numbered or named the lessons according to the corresponding topics in the Stewart's Calculus Early Transcendentals 8th edition book. So it's easier in my case to actually name the sections by that book. But anyway, the lectures are in the logical order of the topics. So in other words, even though they have these strange numberings, like for example 12.1, 12.2, and so on, they follow in logical order, obviously. But the name or the numbering is just because it's a little bit easier, if I want to assign homework. To actually have the lecture named by the way the section is named in the book. What about the content of the course? I have a couple of important remarks here to make. So there are essentially 5 major units, vectors in geometry of space. This is usually an easy part of the class, but it's a very important one, and this might be a little bit of a difference compared to other instructors. I like to spend probably a little bit more time than usual on this section. Because especially those of you who didn't actually learn anything about vectors before, while this part is easy, it's extremely important because we're going to use vectors and operations with vectors throughout the course. And you simply cannot afford to actually have some misunderstanding of what the notations mean in terms of vectors, what a dot product is, what a cross product is or represents, all of these operations, which will pop up all the time on the later topics. So you need to have all the energy to focus on the actual more challenging part, which comes up, in the second half of the course, maybe, or most of the course anyway. But especially the second half of the course. So it's not something you want to go quickly, unless of course you cover these topics before, in which case of course you can go faster or skip it altogether. Next topic is vector functions, and we can actually split these units. There's just some rain outside. No, I hope this is not going to ruin my video. Might be a little bit of a strange sound when I go over this. So vector functions, partial derivatives, multiple integrals, and vector calculus, all of these are the major units specific to calculus, so to speak. At this point, I just want to mention that from a mathematical standpoint, all of these deal actually with 3 types of functions which are specific to calculus 3. Right, in calculus 1, to make a remark here, in calculus 1, you have a single variable function, right? So you have a function that takes a real number and associates another real number. Specific to calculus 3, we have vector functions which take a real number and associate to it a vector. We'll define what that means starting with the second lecture. these topics on partial derivatives, multiple integrals, mostly deal with another type of functions, the so-called functions of several variables, in which the function takes a pair of numbers, or in 3-dimension, 3 coordinates, and associates a real number, also denoted by this, right? This is a function of 3 variables. So again, the argument of the domain is a pair of numbers in the plane, or 3 coordinates in space, and associates to it a real number. And finally, the vector calculus, which deals with the most general type of function, takes a vector and associates that to that vector another vector. So the so-called vector fields. Takes a vector and returns a vector. That's the last unit. So it's like we have 3 major types of functions as main tools specific to calculus 3. Specific to calculus 2 because we still have old-fashioned single variable functions popping up, right? I mean, once in a while, but that's something you encounter already in calculus 1 and 2. There will be, like I said, a lot of visualization. It's very important to get into the habit of sketching by hand various shapes, and there is a little of an art here in the sense of sketching just enough what's needed in order to set up the problem, but not more, because it's very hard to do by hand an accurate picture. And I'm definitely not a talented person. I just know and do enough sketching to actually visualize what is needed in the problem, so I can set up the problem itself, like an integral. Most of the time is the issue of setting up the correct integral to solve a certain problem. Whenever, of course, we need a more accurate picture, we're going to make use of Maple, in my case, or any computer algebra system. These Maple presentations that will happen occasionally when we go over this class are important again. It's very important to see exactly how stuff looks like in reality, right? I mean, and that's why you use a computer algebra system. In the absence of Maple, of course, you can use free resources on the internet like Wolfram Alpha, for instance. So Wolfram Alpha, it's not nowhere near as good as a computer algebra system installed on your own computer, but for basic stuff it's probably good enough. I mentioned this already, but let's say it again. Make sure you pause and just maybe rewind if you need to see a computation done again. It's very useful to pause and do the computation on your own, and then check with the video to see if you did it correctly. If you don't use the pause button, I don't think you're going to get what you're supposed to get from these lectures. I'm assuming people actually will slow down on their own and pause so that they can catch up with the notes. It should be basically like the same attitude like in a regular classroom. Inherently, there will be some typos that will pop up later that I might discover later. And if you actually discover one of them, you're more than welcome to send a comment on that video. Usually, if it's a typo that I can actually fix by a simple comment, I'm going to make that comment in a pinned comment so you can see it in the comment on the top here on the comment list. If the video is all wrong, of course it'll be redone. I mean, if it's not possible to, or maybe there will be a correction video. But don't ignore the pinned comments because they are usually referring to typos that may happen in the video. So with that, I hope you enjoyed the course, and that's it for this introductory part. See you later.